Hello there, my name is Anirudh Kulkarni and this is my entry for the HackHC hackathon. So what I've created is a project that helps them to actually live track the vehicles, detect number plate numbers, and also help them keep a track of the traffic signals and how many cars are currently present on them. So as you can see on the screen right now, this is the code that I've written for it. I've used Python for the basic backend coding part of it, and then I've used PyQt5, which is the front end part of it. It's also written in Python. So I've basically created a UI. I use a Qt designer to actually create the GUI according to my liking. Then I've also created a HackHC ML classifier, the machine learning classifier, that's going to help me detect the cars. Like cars as objects is going to detect that using the positive and negative images, and that's going to help me to actually detect how many cars are present on the road. Suppose I give this image as the input to my model, it's going to give me the output as the number of the plate of the car. So I've created this model using the YOLO version 3, the tiny YOLO version 3 model, and these are the basic hyperparameters that I've kept for training this model. So I've trained the model for about 150,000 iterations, and I think it's giving me a pretty good accuracy part. So I've also included a live tracking algorithm which uses the CSRT algorithm which is present in the OpenCV module to actually track the vehicles that are currently moving on the road. So this is basically just the machine, the deep learning network that was being trained. So I just recorded this when I was training this about at the 50,000 iteration or something like that. Let me just show you how the code actually looks like. So this is the GUI that's created using PyQt5. Basically, use the CSS styling that's going to be used. Let me just keep that there. Let's run the traffic per road part of it. All the number of cars that are present were detected, and I've basically also added this information in a database so that later on I can train a machine learning model to actually predict which signal will have the most amount density of cars at which point of time in the day. So that's a future scope for the project maybe. This is the number plate detector which I have used. So as you can see, I'm running these processes simultaneously. I'm not running them one at a time because I've made sure that I run these in different terminals while running the code. So this is the output that I get after running the number plate detection. Like the original image which I had given, now the numbers are being detected here. So that is done using the YOLO model 3. And this is the live tracking part of it. Alright, so this is the sample video. I'm going to stop the frame and then just choose the region of interest that I want to track. So this is the region of interest. Now as you can see, the car that I've tagged is basically being tagged by the algorithm that I've written. So this is how the project works. You don't necessarily have to run one process and then move on to the next process. You can continuously keep running these processes simultaneously. So even if you're done with the live tracking part of it, now you can use the number plate detector to actually detect the number plate of the car. So this, I feel that this project is really going to help the police officers and in general the security systems. This can be used in various security systems too, and that is why this was my hope to provide such a project for this hackathon. I hope you liked it, and all the codes to this are present on my GitHub repository, and I'll paste the link in this video too. Thank you so much.